Dead Men Tales is brought to you by SupplyHouse.com, the easy way to order HVAC, plumbing, and electrical parts. Shop online, find a wide selection of products from industry-leading brands, and get fast delivery anywhere in the U.S. And being a pro has its perks. Apply to be a SupplyHouse.com Trade Master and get access to a dedicated phone line, free shipping and returns, and discounts on every order. Join the thousands of trade pros already benefiting from their free membership at supplyhouse.com/trademaster. That's supplyhouse.com/trademaster. From heatinghelp.com, it's Dead Men Tales. I'm Dan Holohan. America has plenty of old buildings heated with steam or hot water, and some people love those radiators, while others hate them. But they're there, and we have to deal with them. So I'll share with you some tips that I've picked up over the years from the dead men and the old books. I hope they make you look even smarter. Steam heating arrived first, and since steam is lighter than air, it will always rise to the top of a radiator when it enters from the bottom, as it does in every one-pipe steam radiator. It also tends to stay at the top of the radiator when it enters from the top, as it usually does when it's a two-pipe radiator. Most one-pipe radiators had nipples across only the lower part of the radiator sections. We call these column radiators. They're the ones with the wide sections. The steam entered from the bottom and rose, displacing the air as it did so. The air moved from section to section and then left the radiator by way of the air vent, which was always in the last section. You'll have a tough time trying to use column radiators on a hot water system because you can't vent the air from the individual sections. You'd have to drill and tap each section for an air vent, which would look dopey. So that's a good place to look first if you're thinking about converting an old steam system to hot water. Do the radiator sections have nipples across both the bottom and the top? If they do, they're probably hot water radiators, which the dead men started using on steam systems around 1900. That's when vapor heating became very popular. Vapor heating is a system that runs on very low pressure, from 0 psi to 8 ounces, and never higher than that. This system became popular around 1900 because before that, when central heating was new, the contractors were putting in systems that blew up an American building every 36 hours. They thought it was normal to have 60 psi pressure at the radiators back in those days. Blowing up buildings became sort of a national sport. In 1898, the Carbon Club, which later became IBR, passed some rules that had to do with pipe sizing and pressure drop, and they made the bold statement that from that day forward, there wasn't going to be a steam-heated house that couldn't heat on 2 psi pressure or less. Things got better right away. The hot water radiators on those vapor systems had 2 pipes, and the supply pipe usually entered the radiator at the top. The steam worked its way across the top of the radiator, giving up its latent heat energy to the cool cast iron, and its sensible heat as well, because the condensate dribbled from top to bottom. Compared to a one-pipe steam radiator, two-pipe vapor heating felt so much nicer. Those radiators running at low pressure and heating from top to bottom gave a more even radiant glow, and it all had to do with those upper push nipples. Many of the vapor radiators had no steam traps. Instead, they used an orifice device, either on the outlet side of the radiator or within the supply valve. An orifice is a small hole through which only a certain amount of steam will pass at a given pressure. The dead men used charts to tell them the proper pressure for any given day depending on the outdoor air temperature. This is why it's so important to operate those old vapor systems with a vapor stat rather than a standard pressure troll. You need ounces of pressure, not pounds of pressure. Too much pressure will push through the radiator and pressurize the return main, and that will keep nearby radiators from heating. Some of the old radiators had supply valves with a lever type of handle. The lever had a metal pointer that you could position over these raised gradations on the supply valve's bonnet. When first setting up a system such as this, the dead man would move a peg on the valve's bonnet so that the supply valve could open only to a certain point and no further. He did this because this type of radiator valve contains a variable orifice, and each one of those markings on the bonnet represents 10 square feet of radiation. The dead man would install a radiator, let's say this particular radiator could put out 100 square feet of equivalent direct radiation, he would then set the valve at the 80% of maximum mark, which would be 80 square foot EDR in this case. When an occupant opened the valve fully, no more than 80 square feet of steam could enter the radiator when the boiler was at a certain pressure. And since the radiator is capable of condensing 100 square feet of EDR, the only thing leaving that radiator would be condensate. That does away with the need for a radiator steam trap. This brings us to today, when a contractor might remove that old supply valve because it's broken and replace it with a modern supply valve which contains no orifice. It's wide open. The steam will now blast through that radiator and enter the return lines, where it will block air from leaving other radiators, keeping them from heating. The usual reaction to this is to raise the steam pressure, which just makes things worse. The real solution is to install an orifice plate in the union connection of the new supply valve. The dead men often cut their own orifice plates from their Prince Albert tobacco cans. They just snipped a circle about the size of a nickel and punched a hole in it with a nail. Install that inside the supply valve and you're good to go. On those old hot water systems, the dead men would use radiators that had nipples across the top and bottom, of course, and since those old systems worked by gravity circulation, circulators didn't arrive till 1928, they would connect the radiator bottom to bottom. The hot water would enter the radiator at the bottom and rise to the top because it was lighter than the colder water that was already inside the radiator. The colder water would fall out of the radiator through the pipe on the bottom of the radiator at the opposite side and return to the boiler. That set up a nice convective current. But when a contractor adds a circulator to one of these old systems, the hot water will zip across the bottom of the old radiator and leave through the other side. When you go on the job, the radiator feels hot at the bottom and cold at the top. This is because the water is moving too quickly to set up a convective current within the radiator. It appears to be an air problem, and you're tempted to bleed the radiator, so go ahead and try. But if you don't get any air when you're bleeding, it's not an air problem, so stop bleeding. What you have to do now is slow the water as it enters the radiator so that it will set up a convective current within the radiator. Want more heat? Throttle down on the inlet valve. Don't open it up. It sounds crazy, I know, but it works. Here's something else I had to learn the hard way. Some of those older hot water jobs had no compression tank. Wander around the building as much as you want. You're not going to find a darn thing. So how did the system operate without popping the relief valve? The dead men left the air in the top of each of those bottom-to-bottom connected radiators. The trapped air combined to act as an air cushion to take up the expansion of the hot water. It was ingenious and it saved them money. But then along comes the modern installer. He works on the system and bleeds the air from all the radiators. He thinks he's doing something good. What he's doing is moving the compression tank. And that's when the relief valve starts to pop on every call for heat. I had to learn that one the hard way. Another thing I had to get through my thick skull is the fact that old hot water radiators contain a lot more water than fin tube baseboard. Nowadays, the boiler manufacturers rate their boilers using a piping and pickup factor of 1.15 for hot water systems. That's fine for baseboard and even for radiant, but if the system you're working on has old radiators, and the big pipes that usually accompany those old radiators, that 1.15 pickup factor isn't going to be enough. This is why all the boiler manufacturers show a boiler bypass in their installation instructions. Without that bypass, or primary-secondary piping, the new boiler will never reach its high limit temperature. It will use more fuel than the old boiler used, and it will make everyone involved with that job miserable. But it won't make you miserable because you're the one with the answers. So go get them. Hope you enjoyed that tale. And if you did, please share it. And if you haven't already, please subscribe to this podcast. I have many more Dead Men tales to share with you, and I really appreciate you taking the time to listen. Thanks.